Greetings. In this video, we'll discuss UV mapping. That is applying the information that will allow you to paint a texture in a digital imaging application. Let's prepare the model first. This model has all of its history intact. We can see some of the shapes that we extruded. Here's a list of all of our moves, and if we're done with the model, we can get rid of that. What you'd want to do first is do a save scene as and say complete model, finished model. And that way, if you wanted to go back to any of your previous workflows, you'd have that option. I'm going to come up and go to delete all by type. Take a good look here. There's by type, which means only for the selected object, which would work in this case. But I'll demonstrate here, delete all by type history. So all the history in our entire scene will be wiped out. And it cleans everything up. Now we can get rid of any extra nodes, and we're left with just our model and a clean input in the channel box. So again, increment and save or save as, and as we move into UV mapping, rigging, animating, we don't need all that history information for our model. Okay, we are going to talk about UV mapping, and we're going to open the UV editor. If we look at this here, we can see that the initial shape, you can see the cylinder and you can see that cube, but this wouldn't work for us. In fact, its relationship to the model is tenuous, right? We can barely make out what it is that we're seeing. So our goal to create a UV map is to lay this three-dimensional object out onto a two-dimensional image. Then we can take that two-dimensional image into an application like Photoshop. We can paint on it, and then we can bring that image back and overlay our three-dimensional object. So that's what UV mapping is, essentially taking a 3D object and laying it out flat. Can be a very complex process, and you might have two very experienced UV mappers, and each one would come up with a different strategy or even a different UV map. So that's one of the reasons we're executing this on a very simple model. It's one of the reasons that I had you follow along so that we have essentially the same topology so that we can follow this initial UV map. The other thing that I'll say is we're just going to UV map the top and bottom. I'm going to exclude these cylinders because they're a little bit more challenging. We'll tackle those in the coming weeks. So our first task is to lay this out. In my UV editor, we've got the toolkit, we've got a listing here, and we've also got a list of commands here. Lots of overlap between those three areas. We'll first come to create planar. Well, actually, let me just, as an aside, there are many ways to get an initial UV map. Let's try automatic, though I'll undo it in just a moment. I'm going to say create automatic. And you can see that it's taking that 3D object and cut it apart and laid everything out flat. The automatic, with each iteration of Maya, gets better, but it's still not perfect. And it's very rare that you can just automatically map from the beginning. The automatic map works on areas of a model well, but it rarely works on the entire model all at once. So I'm going to hit the Z key to undo that. And we'll come to create. We're going to use a planar, which is just a straight ahead projection. And if we look at our model, looking straight down would be the best place probably to start. So I'm going to say create planar. We're going to open the dialog box to make sure that we're looking down the Y. So Y-axis is selected. Right, here's our Y-axis. That's going to project just straight down. And we'll hit project. And now you can see that model and the UV map. It makes sense now visually. But let's talk about why we have additional work to do. This would allow us, if we were to export this UV map and open it in Photoshop, it would allow us to paint the top. But if I pick this face right here, for instance, you can see in the UV map that's sitting sideways. We need that to also be laid out flat. As well, if I were to come and pick a face on the bottom, visually you can see that, but you'd actually, if you were in Photoshop painting, you'd actually be painting this face. There would be no way to paint underneath. So our first task is to cut the top and bottom away from each other. But before I even do that, I'm going to cut off these engines here, just because they're a little bit too complex for us this first time through. We'll reserve that for an upcoming lesson. What I want to do is pick these edges, and we'll cut along edges. What can also be confusing, that the edges that we select and cut for UVs doesn't have any effect on the model. So while there's a visual relationship between these two things we're looking at, the three-dimensional polygonal mesh model and the UV map, and they share components, they are completely different, and they will end up looking different as well. But I'm going to cut along edges. I'm going to select an edge loop. I'm hitting the F key just to come around, hit that and this. So if I hit the 4 key, you can see I've got that rectangle. Remember that we created this with these two edge loops so that we could attach or bridge or weld the shape together. But now I've got that rectangle. And what I'll do is come and turn symmetry on. Let me just demonstrate this. I've selected it on one side. I also want it selected over here. Rather than doing it twice, I can make the selection on one side and then just come and hit Object X. And now it's, oops, let's see. Sorry, we'll do that in the modeling toolkit. Object X, there we go. And it selected that edge on both sides. Now we'll execute a tool. Down here, let me just shut these so we're starting on the same page. Come down in your UV toolkit to to cut and sew, and we'll hit cut. Now, this is confusing. We did not cut on the model. We cut on the UV map. So if I look at my model, if I come here and pick, it's still a singular shape. We can see that in the outliner there's still just one node here. But if I come now and choose the UV shell, when we begin to cut UVs, the new UVs are called shells. I'll pick this shell, I'll select the move tool, and I'm just going to move this out of the way. Again, we're going to handle this later. It's a little bit more complex than just laying the top, bottom, and sides out flat. So we'll just tackle the main part of the ship. We're setting this off to one side just for a moment. Now we want to cut the top and the bottom. And you have, as I mentioned before, there are many different approaches, but let's all stay on the same page as we're learning this. And later in the semester, when you create a more complex spaceship, you'll be able to determine where you would like to make the cuts according to how you would like to paint the model. I'm going to cut the bottom though. I'm going to come and we have symmetry on again. Symmetry is on here. And we'll just pick the edge that goes around. I'm hitting the select tool or the Q key shortcut. I don't want that move tool on while I'm just making selections. And I'm going to come around and just pick all the edge of the bottom. You may need to pause and rewind and watch that a few times to see which edges that we selected. But here in the wireframe you can see that there is an edge. There are no gaps in it except for where our previous cut was. So we've got essentially a closed edge that runs all the way around the bottom. And we'll execute that same tool, cut. We'll right click, choose the UV shell. With my move tool, I can move that over. And you see now we have a clear view of the bottom of the ship. If you're ever confused about what you're looking at, you can pick one of the components and then see what highlights. So we can see very clearly this is the bottom of the wing, and I could paint on that in Photoshop, put insignia, copy and paste photos, anything that I wanted to do to generate that texture. We still have the problem if we look at the top, right? We can see that this is the top, but the sides, I'll pick this side and we can see that it's still not laid out flat. It would be impossible to paint a clean or clear texture map there. So we could execute that same kind of technique and cut the sides apart, but there's one additional tool I want to show you just in this very, very basic overview, and that is the unfold. So I've got this shell selected, the top. It's got sides that need to be laid flat, and the unfold algorithm, you can see, does a pretty good job. I'm going to hit my rotate and just straighten that up a little bit, of laying that out flat. We can see the cockpit if you want to pick a face to see what's highlighted, but now we also see the side, and we could paint. Maybe there's some insignia there. You would be able to easily paint that. We can see the interior, right? The interior of our input, and if we were painting, right, the exhaust, we could very easily paint that. There are seams, and there will always be seams. UV mapping is similar to clothing in that your clothing started out as a flat roll of material. It was cut according to a pattern and then sewn together. So that analogy of pattern making for clothes applies here. We will always have a seam in the same way that your clothes have a seam. You want to put those seams in the least conspicuous place, and when you're painting the textures, make sure that you're aware of where the seams are as you paint. The final thing we'll do is put this all into the same UV space. I'm going to just pick UV shell, select everything, and with my scale tool, we're going to make it so that it fits all in this initial box, this initial square. It looks like I need to scale it a little bit more to fit, and we'll move it in there. This is because if we're ever going to use this model in a real-time application like a video game, most video game engines only look at this this initial square. If you're doing animation for playback, and depending on several factors, the space may be you may be able to use these additional spaces. But just to keep things as flexible as possible, we'll limit ourselves to the 0, 1 UV space. And you might say, well, why did we make it smaller, or that there's some disadvantage to making it smaller? We can export this at any resolution size that we want. Now, when you submit your work this week, I'm going to open your file, and I'm going to open the UV map editor, and I want to see something similar to this, that you've cut the top and the bottom, and you've cut off the jets, and that you've unfolded the top so that you could paint the sides. We're not going to paint this week. In upcoming weeks, we'll talk about going to a digital imaging application. And let me just mention that for those of you who maybe want to experiment, in order to get this out of Maya and into Photoshop, for instance, we want to select the object. So I have the object selected. It won't export if you're in component mode. So have the object selected, and then we'll come to Image and UV Snapshot. And when I open that UV snapshot, here is where you can change the resolution size. So if you made it 50% smaller, you could make your resolution size twice as large to compensate for that. So don't let the fact that we made this smaller here, it doesn't have any bearing on the actual resolution that you create in an application like Photoshop. Here's where you can hit Browse. Image format JPEG. You could open that in Photoshop. You could paint your textures, copy and paste textures, save that, and then load that back into Maya. And we'll be talking about that process throughout the semester. All right, give it a shot. Questions in the tech discussion. Have a good one.